Hello everyone, in this video I would like to cover a couple of problems which you need for quiz number 2. In my last video I covered a couple of problems related to lab number 5 as well as they were related to quiz number 2. And in this video I would like to solve those couple of problems using the p-value method. The approach is quite similar. The steps are absolutely the same. We just need to rearrange a couple of steps. Step number 2 and step number 3. So we are going to slightly rearrange those two steps, but all other steps, they stay the same. We formulate H0, we formulate H1, we formulate our claim, okay, and we establish our significance level, which is usually given in the problem. Okay, but then for the critical value method, we calculated critical value based on the significance. Yeah, we used our normal standard inverted function and calculated such a z-score which was cutting that area 0.05 from the right. Okay, so we use 0.95, so this is the area to the left. So 95% of the area, leaving us like with 5% on the right. Okay, so then we calculated our test statistic and we compared our test statistic to the critical value. So it was if it was out of the critical region, so then we did not reject H0. If it was within the critical region, we were rejecting H0. Okay, here we are going to do it differently. Instead of calculating critical value, we are going to leave our significance as is, and instead we are going to take our test statistic and we are going to calculate the area from the right from the test statistic for the right tail. If it's the left tail, we should calculate the area from the left from test statistic. Okay, and that area under that curve, that's what p-value is. And again, the function of p-value is the same. Based on the p-value, we are going to make the conclusion about h0. If we reject h0 and if we do not reject h0, and based on that, we are going to make our final conclusion about the claim. Okay, p-value is equal to this is normal standard distribution, and this is our test statistic. Okay, and this is cumulative, and what it does, it calculates the area to the left, and in order to get the area from the right, we need to take 1 and subtract it. Okay, so this is our p-value. So let's maybe format it up to the third digit, let's say. Oh, look at this, too much. It is 0.093. So our p-value is greater. Our p-value is greater than our alpha. Okay, our p-value greater than alpha. Okay, and if p-value is greater than alpha, then we do not reject h0. Okay, if our p-value is greater than alpha, we do not reject h0. Okay, so we make the same conclusion. As you can see, we are making absolutely the same conclusion. So since our p-value is greater than significance level, we do not reject h0. Okay, we do not reject h0. And as a conclusion, yeah, we do not have enough evidence to claim that professors earn more than 42,000 per year. Okay. So that's what it is. As you can see, absolutely the same thing. Yeah, but in the critical value method, we were taking our alpha, and we were inverting it to the z-score, yeah, to the critical value, and then we were comparing critical value to the test statistic. Here we do vice versa. We leave our significance level, and then we take our test statistic, we calculate the area, and we compare areas. You see, like if area is greater, that means we are out of the critical region. Okay, so if it's less, we are within the critical region. Okay, so let's save it, and let's go for problem number 2. So problem number 2 was two-tail test. Here we need to be careful. So we need to be careful because here we need to calculate, we need to take our test statistic, 2.46 in this case, or minus 2.46. And what we are doing here, we are calculating the area which is cut by the test statistic in the tail from the right and from the left. So we take one of those tails, this tail or that tail, and we double it. Okay, and we double it. So be careful with this. Quite common mistake to forget to double p-value here in the tail, in one tail. Okay, so let's see. So let's calculate our p-value. Let's calculate our p-value. So this is our p-value, and our p-value is equal to. So let's take this tail, because here we can right away calculate. We can calculate the tail. So it's here we used t-distribution, since the standard deviation of population is unknown. If the standard deviation of population is unknown, we use t-distribution. Okay, so we use t-distribution, and here we are going to calculate the area under the curve from the left of the test statistic, and then we are going to double it. So it's 2 multiplied t-distribution, and it is minus 2.46, and degrees of freedom is 9, okay, which is n-1. Okay, so we have like this, or we can, if you want, I think it was a little bit, we had a tail there, so we cut it here. Let's maybe just take it, so it's minus this, yeah, right, so it's going to be a little bit more accurate, and then we will take 9, and it is cumulative, yeah, so we are calculating area from the left, from the test statistic here, and we double that area in that tail. So that what is going to give us the p-value. Okay, and we say go for it. Okay, and as you can see, in this case our p-value, so our p-value here, it is less. So here we see we have it 0.0361, and our significance level is 0.05. Okay, so our p-value in this case is less than alpha. Okay, our p-value in this case is less than alpha, and if p-value is less than alpha, then we reject H0. Okay, if p-value is less than alpha, we reject H0. Okay, so same, as you can see, same conclusion, because again the approach itself is very similar. We just rearranged a couple of steps, that's it. Yeah, but we consider absolutely same distribution, absolutely same parameters, like same test statistics, same significance level. So everything is the same, but for the critical value method, we calculate the critical value based on the significance level, and we consider it to test statistic. For the p-value, we leave our significance level, we take test statistic and calculate the area and compare the area. Okay, but again, like the purpose is the same. to make the conclusion about H0. We reject H0 or we do not reject H0. Okay. So let's save and let's go to confidence interval.